my phone on quiet, shall I? Oh, yeah. What's he going to do about you? Not much chance you're going to be quiet, is there?
So I reviewed this FNIRSI soldering station before, and I quite liked it. Now, one thing I've been getting in the comments is people saying that I haven't checked the earthing of the soldering iron tip and stuff like that, and there's apparently reports of being like 90 volts. So I thought I should probably look into that, and I just did. And I did check, and yes, I was getting 90 volts AC on the soldering iron tip. However, it's only at between about 80 to 200 microamps. I measured the current by shorting the earth onto the tip, and I could measure the current there. That most is 200 microamps. The lowest I saw was 80 microamps. So it's not a huge current there. So what I'm wondering if we can actually do is actually pull this thing apart and maybe fix that problem. We'll see. Maybe we can, maybe we can't. So let's do some investigations first. You can see I'm prepared here. Soldering iron tip plugged in. I've unplugged the lead which runs to the base, which is normally used for the sensing, so it goes into the casing here. So between the lead and there, there's like 0 ohms, okay, or 1 ohm. So that plugs into this. So you'd think normally that would be an earth. It's not an earth. So let's check onto the pin to the soldering iron tip. Also, no earth, no resistance whatsoever. So if we go from the earth pin to any connector pin on here, so we'll look, see what we get. Onto the casing, nothing. Pin 1, 2, 3, 4, 5. There are no earths present on that connector there at all. Or that earth pin isn't connected to anything. So it screws in the bottom here, underneath the feet, looks like. Let's pull one foot off and I can see a screw down there. Right, take the last screw out. Not sure if the side pieces have to come off as well, but they're okay. Right, that's what's inside. So it does have an earth connection to the PCB. So that pin is actually used. Main power supply there. Gives different angles on it. So main power supply does have an earth, but look, there's no connection there. Look at that. It's going to the PCB, and then there's an unpopulated pad. Oh, that's interesting. I wonder what that's used for. I might take the power supply out. Okay, and there's the control board. Same deal, get some different angles. There's an archery processor there. Same as FNIRSI seem to use and everything. So the extra soldering iron connections on that connector on the back there come through this bunch of wires here. So there's 4 wires with a 5-pin plug. Interesting. So, but there's provision for 6 wires on the PCB. Let's get this PCB out and see about the earthing on this thing, because I really want to do something about that. Right, so I've taken the screws out of the power supply. Falling out everywhere. It's like the same screws, hold the casing on. I'm going to have to fold it out. Now there could be high voltages in here. Now what I'm looking for is to see what's going on with this earth point. It goes nowhere and it does nothing. You are kidding me. So the earth goes onto the PCB just here. Let's get a close view. Right, here's that unpopulated component. You can see there's a wire just the other side there, so it is, you know, designed to go somewhere. On the other side, there's the earth connection just there, coming in. Nothing around it. There's the wire from the unpopulated component. That comes around onto the secondary side of the switch mode and comes down to some circuitry here. What's that going to? 0 volt side. So it's supposed to be tying to 0 volts to ground, and it's not, because there's no component in there. I wonder why they decided not to do that. I mean, there's a decent isolation gap, so there's no groove obviously, but there's a decent enough gap, that's alright. That'd be an opto-coupler across it. Yeah, sure enough. Big caps and what have you. But yeah, I'm not going to measure caps and touch stuff, but it looks like there's no earthing because there's one component which is not installed. Wow. So that just ties 0 volts to ground. And I would say it's probably a good thing to do. I'm going to put a resistor in there. In fact, before I try it, let's actually do some measurements and see if that 0 volt, well, yeah, the minus, I suppose, the minus on there, actually goes through to the soldering iron tip, because if it does, then that will solve the problem. If it doesn't, then it may not solve the problem. Yeah, I've got to figure out which wire it is on here first, and I'll go from there. I'm not quite sure how I'm going to do this actually, because I need to plug it back into the top part. It's got P minus and P positive marked on here. So the power minus does indeed go to the negative connection. And that's this black wire. So we shove a probe in there carefully. We'll try not to damage the connector. Check that against the probe. And that's 1.1 ohms, which is 1 ohm of the lead resistance. So yes, if I ground the negative, that'll ground the tip. Wonder why I didn't put that component in there. So I've decided to go for a 2 ohm resistor. I was thinking about the actual voltage that's applied here. It's 90 volts, 200 microamps. 1 mega ohm isn't going to do anything. It might drag it down to like 70 volts or something, maybe a bit less, but it isn't going to do much. Now I already tried using the low ohms on my flick meter here, on here. So I tried that already. That's a 1.2 meg resistor inside that, and that did nothing. So I already proved that 1 meg was not going to be good enough. Although you like to have isolation, tip grounding, it maybe could be tied down quite hard. So I'm going to try 2 ohms, and I could put in like a 1 ohm or even a 0 ohm resistor in here, but I'm wondering why they decided to leave that part out. So there may be a reason for it with this power supply design. Maybe there's something you didn't like. I don't know why that would be the case, but just to play it safe, I'm going to put in a low ohm resistance. So at least then it's still got a chance of acting like a fuse if something goes wrong. Yeah, we'll see what happens there. So I'm going to put this in. Now, next dilemma I've got is, how do I solder onto my soldering iron? Bit of a catch-22 there. Mind you, there is a better solution to this. I've got my Jobe soldering iron sitting right here. I can use that one. Alright, let's put a bit of flux on here. Try to set this up so you can see it. Whether or not we'll be successful with that, we'll see. But I'll see. Maybe you won't see. I'm not quite sure. Anyway, touch of flux on there, tiny little bit. And I'm going to put a little bit of solder on one pad. And then I can do the other pad afterwards. A little bit of solder on one side. You might get my tip clean. Move this out of the way because the wires are moving around everywhere. Right. Just not wanting to take. Well, this is going to be annoying if it doesn't take. Good heaps. There we go, now it's going. Alright. Now I've got loads of solder on there. Might need another solution for this. I have another solution. Let's put some more flux on. I think it's going to need it because it is being a bit stubborn. So this is 2 ohm I'm going to use. We'll just see how it goes. I want it to be precautionary. If this works fine and it doesn't get hot or anything, then you could probably go maybe a 1 ohm or even a 0 ohm perfectly safely. I expect you probably could anyway. Anyway, so here's the part. There. Well, I've got my new secure soldering tweezer. We could use this. That makes sense, doesn't it? So let's pick up the part and try to put it in here without dropping it. And let's touch up each side just to make sure I definitely got it right. No, I didn't. It's moving. Okay, these wires are in the way, it'll make it a bit harder. Let's see if I can position myself a bit better. I'm not fighting the wiring at the same time. Problem is now I've got too much solder on there. It's floating a little bit. Okay. I think that's soldered. Let's find out. So let's go between the 0 volt pin. Well, it says minus on the ball, but it'd be 0 volts, wouldn't it? And the earth pin. Yep, there we go. 2.2 ohms. Great. That's working fine. That is soldered. Let's put it back together and see what happens. Right, I thought I'd better give us a clean before I actually put it away. Put it back together. Get the flux off, which I had to put on to get the thing to work. It's fine. Don't want to have residues left behind on mains powered equipment. Could be dodgy. So something I'm not liking on the construction of this is I've just realised when I'm putting it back together, you've got these wiring assemblies here which go through obviously to the handle piece, and it's got these wires running around. Now this is just laying across all the AC sides, so there's like the insulation is what's protecting you on this wire from potentially high voltage ACs. That's not so good. These should really be sleeved. Let me see if I can do something about that. So I've got some of this cloth tape here. I'm going to use this, I'm going to wrap it in the cloth tape, and I'll do the same thing for this power cable here as well, because it may potentially end up rubbing on the edge of these heat sinks, and you don't really want that to potentially short out either. In that aspect, the construction's not the best. I've also got this USB-C cable here, which I probably need to do the same thing too as well. That goes to the USB-C port on the back there. So I'm going to wrap all those cables, and that's bound to improve things a little bit, isn't it? So what I'm actually wondering, I'm plugging this USB-C cable back in again. As you can see, I've wrapped all these felt tape now. Maybe they removed the earthing because of the issues of the USB-C port. Maybe the USB-C earthed directly was potentially an issue because there's no isolation between the USB-C negative and the earth. Maybe it could cause issues with equipment. I mean, could it be that? Anyway, I put a 2 ohm resistor in there, so it's going to lock a fuse. Let's actually do a measurement and make sure that it's doing what it's supposed to do when I have it plugged back in again, once I find the end of the wires and stuff. So we should be seeing a very low resistance between the tip and the earth pin. Hopefully you can see it on camera. Right. I get the good connection on here. There we go. Less than 2 ohms. Dodgy connection, don't forget. Put it onto the casing instead. Be better. 2.4 ohms. Some of that is actually these leads. It's 0.2, so it's about 2 ohms, which is what I expected because that's the resistor I put in. So that's a good start. That looks like it will probably work. Now what could happen is this could go horribly wrong. It could go bang when I power it up, or that resistor could start overheating because there's too much voltage and too much current available to it there, even though the current wasn't that high. Say 200 microamps at most is what I saw, but you never quite know. Things could change. I'm going to plug it in, we'll power it up on camera and see what happens, and I'll get my thermal camera out and see if that resistor gets too hot. Let's power this up. Power switch on. Got blue light in front, we'll push the blue light. That's powering up. It says there's no tip. Guess I didn't push it in properly. It says there's no tip. That's great. Really? Now I can't sense tips. Is that when I took that resistor out? Messed up the tip sensing. You know what it is? I've got to plug this in. So what I've got to do I'll plug that in, then it can actually see there's a tip. It relies on that to know the things in its holder to make it safe. There we go. That works. So that's now heating. Great. So it still works. And it's doing its thing. So it's not broken. Thankfully. Why didn't they put that part in there at the factory? Is it a mistake? Did I leave off the bomb? Seems to work fine with the resistor in there. So let's actually check to see if it's getting too hot. I already have my thermal camera here. Oh, there's a little green light on the PCB there, that's nice. Alright, thermal camera. Nothing showing up at all. Just be careful what I'm touching. Let's get the iron out and let's just slow it down so it's actually heating. And that resistor is not even featuring. NTC, I'm seeing that, but the resistor isn't showing up at all. So I get down the side here, tip it over a little bit. That hot spot is the NTC, which is fine, that's completely normal. And below that, about there where the crosshairs are, that's where that resistor is. It's not even featuring. I mean, maybe there's a slight little bit of warmth there, like almost nothing. It's fine. So the next test is how much voltage we've got at the tip of the iron. So I've plugged my probe into earth over here. So obviously it's heating. Volts AC with no loading on it. What are we getting? 260 millivolts. That's fine. Also I thought for completeness we can do DC volts as well as AC volts. So DC volts, going to get basically nothing there. Right, getting 50 millivolts DC on the tip, and the AC is obviously 200 millivolts. So that's not an issue, that one causing damage when soldering. I think that's perfectly fine now, certainly not better than 90 volts. Well, there you go. If you know any reason why they would have potentially omitted that component so the tip was no longer grounded, so it's isolating the 0 volt rail off the DC side of that power supply. I mean, it looks like they either forgot to install the part, which is a bit unusual, or they intentionally omitted it for some reason. If you can know why that could be, comment down below. I do want to hear your opinions on it. I mean, I don't have a lot of experience of this kind of thing, like the actual design of power supply isolations and stuff like that. Why they would do that, it's not my expertise. I fix stuff, so not quite the same area. So if you know why, comment down below. But obviously installing a low value resistor worked absolutely fine. Maybe there's a side effect from that. I may find out in time, but right now it looks to be perfect. So you could probably go 0 ohm to be honest, but yeah, it's probably a bit of a risk with that. Rather keep a little bit of resistance in there. So if you've got one of these things, I highly suggest you solder a resistor in there. Get that voltage down, because it's not good soldering components with 90 volts AC on the tip. I wish I'd noticed that in the original review. Other stuff to watch down there. Subscribe over here if you're interested. And Patreon support link if you want to help support me on Patreon. All the money goes back into the channel, helps me to buy equipment and do videos. Catch you later.